A very pleasant morning to everyone. Welcome to a brand new edition of AI WorkOne, your premier daily analysis of artificial intelligence, machine learning, and high-performance computing. Today is Monday, June 22nd, 2026, and we are kicking off the week with a comprehensive look at the state of the global artificial intelligence infrastructure. In today's episode, we will dissect the current pricing trends for enterprise compute, including H100, A100, and TPU instances, and evaluate how lead times for GPU supply are shifting from critical shortages to a more stable equilibrium. We will also investigate the ongoing debates surrounding scaling laws and data scarcity, the latest benchmarks in open weights models, the paradigm shift toward autonomous multi-agent systems, and the strategic pivot of infrastructure operators entering the machine learning market. Furthermore, we will examine the rising viability of local developer inference on consumer hardware, security vulnerabilities like prompt injection, and the global regulatory landscape. Before we begin our deep dive, a quick reminder of our standard disclaimer. The contents of this video are strictly for educational and informational purposes. This analysis does not constitute professional engineering advice, financial consultation, or investment recommendation. The hardware, software, and financial markets related to artificial intelligence are highly dynamic and carry significant operational risks. Always conduct your own thorough research, validate your engineering architectures, and manage your compute budgets and security policies with caution. With that established, let us proceed straight to the charts, metrics, and live market data. We open our analysis with the latest trends in high-performance compute hardware pricing and availability. Across major cloud providers, the spot price for renting a single NVIDIA H100 PCIe Tensor Core GPU has stabilized at around $2.80 per hour, while legacy A180 GB instances are trading near $1.60 per hour. Google Cloud's TPU v5e continues to gain ground as a highly cost-effective alternative for transformer training and inference, holding steady at approximately $1.20 per TPU hour. On the supply side, lead times for custom cluster deployments have decreased significantly over the last 2 quarters. What was once a 12-month waiting list for state-of-the-art HGX H100 nodes has now shortened to an average of 12 to 16 weeks, indicating that global semiconductor manufacturing capacity is finally catching up with enterprise demand. This transition from a critical hardware shortage to a stable supply environment is allowing mid-sized enterprises to build dedicated AI infrastructure rather than relying exclusively on public cloud APIs. For developers and engineering leads, this means the compute landscape is shifting in your favor. If you are training medium-sized models or running high-throughput inference pipelines, it is a prudent time to compare multi-year cloud reservations against bare metal colocation options. The key is to calculate the total cost of ownership, accounting for electricity, high-speed networking, and operational engineering overhead, rather than simply looking at raw GPU rental rates. Moving to our next major topic, the debate surrounding scaling laws and the physical boundaries of neural network expansion. For years, the dominant philosophy in deep learning has been that increasing model size and dataset volume leads predictably to superior capabilities. However, researchers are increasingly reporting diminishing returns when training models beyond the 100 trillion parameter threshold, suggesting that simple compute scaling may no longer be sufficient. The main bottleneck is no longer just computing power, but the availability of high-quality, human-generated training data. With the public internet's textual archives largely exhausted by current-generation LLMs, frontier labs are heavily relying on synthetic data generation and reinforcement learning architectures to bridge the gap. While synthetic data allows for fine-tuning specific reasoning paths, it also introduces risks of model collapse and cognitive echo chambers if not managed with rigorous quality filters. In response to these data limits, the industry is shifting focus from raw parameter size to architectural efficiency. We are seeing a rapid adoption of multimodal architectures and dedicated reasoning engines that execute search and verification steps before outputting a response. This means the future of AI dominance will likely be decided by algorithmic sophistication, advanced alignment techniques, and compute-optimal configurations rather than brute force scaling. Let us now turn our attention to the latest benchmarks and the rapid evolution of open weights models. In recent evaluation runs, the latest open weights architectures are demonstrating performance levels that closely match or even exceed closed proprietary models on standard coding and reasoning datasets. This democratization of high-tier intelligence is fundamentally changing how enterprises plan their software architectures. Specifically, on code generation benchmarks like human eval, medium-sized open weights models are achieving score rates above 85%. This capability, combined with expanded context windows that now regularly exceed 1 million tokens, allows developers to feed entire codebases and documentation, sets directly into local contexts for debugging and generation. The gap between proprietary cloud endpoints and self-hosted models is narrower than it has ever been. For business planners, this introduces a crucial strategic choice. Proprietary APIs offer low initial setup friction and managed scaling, but open weights models provide complete data sovereignty, customized fine-tuning, and zero dependency on external service providers. As tooling around model quantization and optimization matures, self-hosting is becoming the standard path for industries with strict privacy requirements, such as finance and healthcare. Next, we examine the massive paradigm shift from conversational chat interfaces to autonomous, multi-agent workflows. While the initial wave of AI adoption focused on single-turn prompts where a human guides the model step by step, the current state-of-the-art involves deploying teams of specialized agents that collaborate to solve complex, multi-step engineering and business tasks. These agentic systems rely on key design patterns such as reflection, planning, and tool integration. An agent is no longer just generating text. It writes code, executes it in isolated sandboxes, inspects the errors, self-corrects, and queries databases or web search tools to retrieve missing information. This recursive loop allows agentic workflows to complete hours of analytical work with minimal human intervention. For organizations integrating these systems, the immediate impact is a massive acceleration in data pipeline construction, automated code refactoring, and customer support resolution. However, managing multi-agent systems requires a robust runtime framework, clear boundary constraints, and strict execution logging. The engineering focus is transitioning from prompt engineering to system orchestration and state management. In our fifth block, we focus on the practical realities of local developer inference. As local hardware capabilities have advanced, driven by unified memory architectures and dedicated neural processing units, running powerful LLMs locally on workstation laptops has become a daily reality for software engineers. Using open-source runtimes like Ollama, llama.cpp, and Hugging Face libraries, developers can run quantized versions of 7 billion, 9 billion, and even 70 billion parameter models with comfortable token-per-second generation rates. This enables a seamless loop of code completion, documentation lookup, and unit test generation without sending proprietary source code over external networks. The cost benefits of local execution are substantial for engineering teams. By offloading developer-focused assistance tasks from commercial API calls to local hardware, companies can save thousands of dollars monthly in compute fees. More importantly, local execution eliminates internet latency and guarantees uptime, making developer workflows faster, more private, and highly resilient. Our sixth block covers the critical intersection of AI infrastructure, energy constraints, and the hardware pivot of traditional hosting facilities. The massive compute clusters required to train and run frontier models are putting unprecedented strain on local electrical grids, forcing tech giants to search globally for cheap, stable power and advanced cooling facilities. To address these cost and power challenges, infrastructure operators are executing a highly strategic pivot, converting facilities originally designed for high-density processing into specialized AI data centers. By installing advanced liquid cooling loops and securing long-term power purchase agreements, these operators are transforming raw electricity into high-margin machine learning compute capacity. This infrastructure adaptation is stabilizing cloud capacity and providing steady, long-term revenue streams for energy-rich regions. The capacity to secure reliable, clean energy assets is now the single largest differentiator in the cloud computing market. The race for AI dominance is as much a race for gigawatts and transmission lines as it is for algorithmic breakthroughs. Turning to cybersecurity and system governance. The integration of LLMs into active production systems has created new attack vectors that traditional security architectures are ill-equipped to handle. The most prominent of these is prompt injection, where malicious input tricks the model into bypassing its alignment safety guardrails or executing unauthorized commands. When models are granted access to databases, web browsers, and file systems, a successful prompt injection can lead to data exfiltration, system corruption, or privilege escalation. To mitigate these risks, developers must implement strict separation between system instructions and untrusted user data, utilize secondary validation models, and restrict agent execution permissions to the minimum scope required. On the regulatory front, global compliance frameworks are tightening. Organizations must now document their data pipeline origins, verify the fairness of their alignment processes, and ensure auditable records of all automated decision-making systems. Navigating this intersection of technical security and legal compliance is a core requirement for any enterprise AI deployment. As we close our analysis, let us synthesize these trends into an actionable strategic plan for the week ahead. First, assess your compute allocation. With GPU lead times easing, verify if moving high-volume workloads from on-demand cloud APIs to reserved instances or local workstation hardware makes financial sense. Second, design for agency. Begin transitioning your internal automation pipelines from simple single-prompt tools to structured multi-agent workflows with built-in reflection and verification steps. Third, reinforce your security perimeter by enforcing strict API token boundaries and runtime sandboxes, and maintain strict data hygiene by ensuring all fine-tuning datasets are clean, compliant with local privacy laws, and isolated from public repositories to protect your organization's intellectual property. In summary, today's artificial intelligence market demands engineering rigor, careful budget management, and proactive security design rather than simple speculative scaling. If you find this daily analytical breakdown valuable for your operational planning, please remember to click the like button, subscribe to the AI WorkOne channel, and turn on the notification bell. Let us know in the comments. Do you think scaling laws are hitting a definitive data wall, or will synthetic datasets and reasoning architectures continue to push capabilities forward? I am AI WorkOne. Thank you for joining me for today's market and technical analysis. Keep your systems secure, build robust architectures, and we will meet again tomorrow with more live updates and compute analytics. Have a productive day and excellent engineering.